Disclaimer: this project was developed solely for educational purposes. All demonstrations shown in this video were performed in a controlled environment on devices and networks I own or had permission to test. As someone passionate about electronics and embedded systems, I enjoy building projects with microcontrollers like the ESP8266, ESP32, Raspberry Pi Pico, and Arduino. This inspired me to build a compact, programmable device that I can easily reconfigure for different applications. After designing, assembling, and programming it from scratch, I created a flexible platform capable of running different firmware depending on the use case, from simple games and custom utilities to Wi-Fi security research tools for authorized penetration testing and cybersecurity education. For this demonstration, I programmed the device using the Arduino IDE and Flash NetherCap firmware onto the ESP8266. The device scans for nearby 2.4 GHz Wi-Fi networks, allowing a network to be selected for authorized security testing. The ESP8266 hardware supports only 2.4 GHz Wi-Fi, so 5 GHz networks are not. You can see that when the deauthentication test is activated, the connected 2.4 GHz client temporarily disconnects. Once the test is stopped, the device reconnects to the network automatically. Using this, we can block any 2.4 GHz Wi-Fi network. This demonstration was performed in a controlled environment for authorized testing only. Another feature demonstrated in this project is an evil twin simulation. After selecting a target 2.4 GHz network, the device creates a network that mimics the original for security awareness and penetration testing in a controlled environment. As shown in the demonstration, when a test user connects to the simulated access point, a captive portal is displayed to illustrate how phishing-style Wi-Fi attacks can appear to unsuspecting users. When the user tries to connect with this fake network and enters password in captive portal, the password shows up on our device. In addition to these demonstrations, the device includes a wide range of other Wi-Fi utilities. It offers features such as network scanning, Wi-Fi monitoring, and several other tools that make it a versatile platform for wireless analysis, cybersecurity learning, and embedded systems experimentation. The versatility of this device goes far beyond cybersecurity applications. One of its key strengths is that it can be completely repurposed by simply flashing a different firmware onto the same ESP8266 hardware. For example, by installing a gaming firmware, the device transforms into a compact portable gaming console. Using the built-in navigation buttons, it can run a diverse collection of classic games, including Snake, Tic-Tac-Toe, Space Invaders style games, ball games, stickman games, and many more. With around 15 to 20 games available, it offers an enjoyable retro gaming experience while showcasing the flexibility of embedded systems. This demonstrates how a single piece of hardware can serve entirely different purposes through software alone. Whether it's being used as a cybersecurity research platform, a development board for experimenting with new firmware, or a handheld gaming device, the ESP8266 proves to be an incredibly versatile microcontroller capable of adapting to a wide range of applications. Thanks for watching my video. Thanks for watching my video.